Right. Hello, everyone. I'm doing intros now, even though one presenter just finished his presentation. Um, this is Research Jam 25. It's the first one. Interesting. It's the first one of 2025, but it's also number 25, the times they've done Research Jams. So today we have four speakers. One opted out of recording. So we'll have three recorded presentations. So next time, be sure to join live because we get to hear the unrecorded ones and the fun open mic in the beginning. So today, the recorded part, we'll start with Yakaterina.
Thank you. Okay, I will start sharing my screen.
While you're sharing, I'll just mention Yekaterina and I met at NeurIPS at the last NeurIPS, and she mentioned general interest in saying hi, getting to know people, and possibly serving as a mentor for people, which we are always desperately seeking.
That's it. Okay, thank you. So yeah, my name is Ekaterina, and today is actually my very first time that I joined the ML Collective in person, like remotely in person. And as Jason mentioned, I would like to offer myself as a mentor to the researchers of the community, to those specifically who work in the area of natural language processing. And because of that, I want to just self-introduce myself briefly and to tell the community about both myself and a little bit about my research with a couple of examples. Next slide, please. Okay, so I'm a researcher. I'm working on multimodal NLP in human-focused applications, and this is quite a broad area that covers topics like NLP in human-robot interaction, NLP in health, LLMs, and vision language models. So I started my research career in 2012 when I started my PhD program at the University of Bath in the UK. And that period between 2012 and 2015 was all about my PhD. And at that time, I also spent some time at the National Institute of Informatics, where I did a project with my colleagues from Japan. During this whole period, I was primarily focusing on the topic of spoken multimodal human-robot interaction. After that, I did my postdoc at Herod Watt University in Edinburgh, where I, in addition to conversational systems in human-robot interaction, I also focused on natural language generation, and it was the natural language generation pre-transformers, like that era. In 2018, I moved to Canada to the startup that was working in the area of ML in health. And here I focused on using NLP for cognitive impairment detection. And finally, in the last couple of years, I got some quite new experience for me with the nonprofits, also working with the vision language models and LLM applications. And to give you a little bit of personal information about myself, I'm a cat person. Jim is the name of my cat. He's now listening to me very carefully. And he's living with us for more than a year and a half now. It was the foster cat first, but we only survived like for 2 weeks or so before we just adopted him forever. And it's now the foster fail, but it's one of my most favorite failures that I had in my life. I also like.
Does Jim's face always look like that, or is that because of putting this?
I think it's a little bit because of the cloth, but
Okay.
his face is kind of in that type of
Great.
yeah. I also like playing table tennis, traveling, sketching. My favorite place visited so far is Tokyo. I feel sometimes very nostalgic about this city. Hopefully, we'll be back to it soon. And I like reading. My favorite authors are Remark and Murakami. If you like them, especially Murakami, happy to chat about that and his last book. Okay, so let me give a couple of examples about my research now in the next slide, please. Okay, so one area of research that I did is within the topic of NLP for health. And this work specifically that I want to speak about was done while I was at the startup Winterlight Labs, where we developed the AI-based assessment of people's cognitive and mental health status that is based on their speech and language. And we collected speech data usually from the person while they were performing a certain cognitive task using a phone app. So, for example, they were describing some image they saw on the screen of the phone, and then based on that speech, based on their speech and language, we use certain algorithms to decide whether it is a cognitively healthy speech or there are some cognitive issues with that. And there were a lot of challenges actually with this work with these types of applications. And one of them was the challenge of multi-language and cross-language detection of cognitive impairment. So like it's not a surprise that the majority of available speech data sets are in just one language, and usually it's just English. But in addition to these, speech data sets in the medical domain are also sufficiently small. So the problem of the absence of necessary data is very real in this domain. And it prevents researchers from doing work on cognitive impairment detection in languages other than English. So in this project, we decided to develop a cross-language aphasia detection model and tackle the problem of multilingual detection by using a combination of factors. So first, we used the optimal transport domain adaptation system to adapt non-English languages to English. And the second, we utilized out-of-domain healthy speech data for the needs of our use case. And using such a method, we trained the aphasia detection model on English data only and tested it on French and Mandarin, where French is like the language which is slightly closer to English and Mandarin is further away. And it turned out that such a method was very promising and was actually able to significantly improve the performance over unilingual baseline for both French and Mandarin languages, as you can see in that table. And I'm happy to speak more about the details of this project, but probably not this time because I don't have a lot of time right now.
At the risk of slightly running out of time, maybe just a quick question then. If you were to repeat this study today, 2025, 5 years later, what would you do differently? How would it look different in today's world of much, much larger, more powerful models?
Yeah. So today, and that's something that I will maybe mention quickly in the next slide as well. Today, I first of all would do that in the larger scale, like trying to work with more languages, like different approaches to the architecture. I'm still a believer in optimal transport, in domain adaptation. I think it's the approach that is good enough. It's just that that is promising.
Okay, yeah.
Yeah, so I would probably still try to develop that approach with the larger scale.
Cool, thanks.
Yeah, and yeah, next slide, thanks. So this challenge of cross-lingual abilities obviously also important today with the LLMs in general, because LLMs are used by people from different cultures, those who speak different languages, and the language models, majority of language models are work well just with the English, or work the best with the English language comparing to other languages. In my research, since the pop-up of transformers and the large language models, I approached that challenge of multilinguality via two main projects, I would say. One of them was the development of the Bloom LLM, and this was like a big-scale collaborative project with more than 1,000 of multidisciplinary researchers. I will not be surprised if either Roseanne or Jason were a part of this project as well. So it was a big-scale collaborative project, and it resulted in the development of the model that was of the size of GPT-3, 176 billion parameters, and it took 1 million GPU hours and a huge data set. And the model was trained on 59 languages, including 13 programming languages. And another more recent project that I want to mention is like the development of the multilingual benchmark Include. Include is a data set that contains almost 200,000 multi-choice question answer pairs from the exam tests. And that data set was collected from 44 human languages in 15 scripts, and they came from 52 countries. So it's also a collaborative effort with researchers from different countries that collected their specific native language data. And this data set consists of academic, professional, occupational license examinations, and it represents cultural and regional knowledge. And the quality of data was controlled by those native speakers, so it's it's a high quality data set. And we have tested, we have evaluated 15 different models that are state of the art right now on this benchmark, and those models included both GPT-4o and Qwen 2.5, Llama 3.1, Mistral, IExpanse, other models of a variety of sizes. And some of those evaluated models, they do not even claim that they support multiple languages, but at the same time they are frequently used in different languages, like for use cases in different languages. For some of them, we know what was the training data. For some of them, we do not know. So overall, the results were quite different across all these models, and there are interesting findings, like some models perform better on specific languages. Some models perform better on specific type of exams, like professional versus academic, which like give insights on what kind of training data could be there, or like if you know it, then there are parallels in that sense. Overall, the main outcome of that evaluation is that there is still a considerable room for improvement for the models, and like the most probably straightforward way to improve is none of the models that we have tested, at least none of those 15 models, do support all the 44 languages that are within that benchmark. So at least having the models that are pre-trained on a bigger variety of languages, at least that step would already be a good step forward. Yes, I think that's it about the research. Next slide, please. So as I already mentioned, I am open to be the mentor for the researchers in the ML collective community, and I'm open to mentoring either an individual researcher or a small team of people working together on some project. And I see my contributions as a mentor, okay, typo here, as someone who is contributing to research directions, ideas. I am also available for giving feedback on the work in progress, ideas, experiments, and I'm ready to guide and give feedback on paper writing as well. And whenever, if you're interested in natural language processing, specifically like multimodal language models, evaluation of LLMs, data evaluation, please contact me. And the contacts are on the next slide as links, and I hope it will be shared on ML Collectives as slides. So you can just press them. Thank you.
Amazing. Thanks for the intro talk. I think there are many people in the group that would be interested in that have expressed interest in being mentored on projects. So I really hope you and they find the right connections. Can I ask, are you on the Discord?
ML Collectives Discord, you mean?
Yeah.
Yes, I'm on Discord, and please feel free to connect.
Can you put your Discord username in the chat? It might be helpful for people to connect.
Okay, yeah, sure.
We probably should start with Charles.
Okay, great. Let me do a screen share here.
Charles returning for the nth time to talk about a WeightWatcher update.
Yeah, let me try to, I'm just trying to figure out how to share the keynote. Great. Can you see this? Oh, hold on. Okay, can you see that?
We can see your desktop right now.
That's not what I'm trying to share. Okay, I'm gonna try again. Sorry. It says keynote preview share. How's that?
Yep.
Yep.
Okay, great. Thanks for having me. I really appreciate the chance to do this. I wanted to talk a little bit, some updates on this research project I've been doing for a very long time now. Sort of what I'm talking about is a new theoretical approach I've been developing to understand why deep learning works and to provide some tools that practitioners can use to help train and fine-tune models. It's so the new work is called a semi-empirical theory of deep learning. And what I wanted to talk about today is something I realized this year. I've been working on this for several years, and I realized that there is a very deep connection to what we've been doing for some time and something in theoretical physics called renormalization group theory. And I don't know how much this will resonate with current computer science machine learning people, because I've been I've been in this field so long, but it's if you're a theoretical physicist, you would realize that renormalization group theory is actually really fundamental and foundational to modern theoretical physics. So I just wanted to talk a little bit about the connection between what we're doing and this deep connection to theoretical physics and get some feedback. So I've been doing this research for a very long time. We have a number of papers I've been working on. I just give a brief introduction to myself. I've been working with Michael Mahoney sort of informally on trying to develop a new theory of learning for almost the past 10 years, maybe 9 years. We have several publications in the field. The main ones are this paper of implicit self-regularization in deep neural networks. This is our which was published in JMLR in 2021. Really work that was done 2018, takes a while to publish. We have another paper in Nature Communications, where it's sort of merely an empirical study of the techniques we're using. And then the work I'm going to talk about today, which I gave as an invited talk at NeurIPS last year, in 2023, and some of the stuff I've been doing this year. Brief introduction to myself. I did my PhD at Chicago with Carl Fried. You probably know my more famous group mate, John Jumper, who just won the Nobel Prize for AlphaFold. I then was an NSF fellow in theoretical physics, where I was working with Klaus Schulten, who was Jürgen Schmidhuber's PhD advisor, or one of the two of his. And so I was working in this field right sort of when it was getting started. What is the problem we've been looking at? So the problem is how to develop a theory which explains how neural network layers converge. So, I think most people, when they study a neural network, they look at the loss function, various metrics like perplexity. But one of the things I've been trying to understand is, can we develop a general theory of how individual layers converge? And we have a general theory of this. This is this HTSR theory, heavy-tailed self-regularization, which is in the JMLR paper. And there's an open source tool I've written called WeightWatcher, which implements it. And the basic idea is that as you train a neural network, the layers converge at different rates. Some layers look almost random. They don't seem to converge at all. Some are widely underfit. Some layers appear to be overfit. They appear to overfit the training data. Maybe you're fitting to, sort of overfitting, over-regularized. And then there are certain layers which we've identified which appear to be ideally fit. And all of these are characterized by a quality metric called alpha, which is developed in the HTSR theory, which really comes from a phenomenological theory of a random matrix theory approach. And the idea is, if you take any layer in a neural network and you plot the eigenvalues on a log-log plot, and the tool will do this for you, you can plot the eigenvalue spectrum of the weight matrix on a log-log plot. It will form a power law. When we've discovered empirically that good layers appear to be power law, and when they're ideal, they have an exponent of 2. And this is, in some sense, predicted by the random matrix theory. But what I've discovered recently, really in the past few years, is that there's another independent condition on this, is that the tail of the spectral density seems to satisfy a volume preserving transformation, meaning that if you take the sum of the log of the eigenvalues in the tail, that is, you take these eigenvalues which you fit to a power law, and you take the sum of the log of the eigenvalues, you get 0. This is a volume preserving transformation. And this new paper, we sort of talk about where this comes from. The reason this came about is because I was trying to develop a general theory to actually derive an analytic expression for the WeightWatcher quality metric without having to rely solely on a phenomenological random matrix theory. And I've been able to do this using some techniques from random matrix, more advanced techniques, analytic techniques from quantum field theory and statistical mechanics. And the idea is that if you evaluate sort of this fancy integral over a bunch of random matrices, you get an expression which is, you get this expression which, if you do a series of approximations, you can extract out this WeightWatcher quality metric. And so what this means is that you take sort of the limit in the large n case of the logarithm of the expected value of this integral, which is an overlap between, this is a student-teacher model. So it's an overlap between the students and the teacher. And basically the idea is you consider all possible students, which might look like the teacher. You integrate over all the students. You take this sort of, you evaluate this object, which is like a free energy in statistical mechanics. And with a little bit of magic, you can get out this WeightWatcher quality metric. What's interesting about this particular integral, in the case of doing this, you have to restrict this expected value or this integral to just the tail, just that power law tail of the spectral density. And what it turns out is that this is actually related. I didn't realize this. I had rederived essentially a form of what's called the exact Wilsonian exact renormalization group. And so the idea is I want to make a model for how to treat the convergence of a layer or the quality of the layer. So I write down an object like this, which is a free energy. You take an integral over all, you have a student teacher model where R is the overlap between the student and the teacher. And you just simply ask, how many students overlap with the teacher? And the more students that overlap, in other words, how many students actually predict the correct labels that the teacher generates. And so you can write down a Hamiltonian for this or a metric, and you evaluate e to the n beta, trace h, where h is this Hamiltonian. This is subject to this scale invariant or volume preserving transformation, which turns out to be exactly equivalent to a single step of renormalization group. And
Charles, can I ask a question?
Go ahead.
Maybe two quick questions, not wanting to derail us too much, seeing that we're on slide 6 of at least 12. First, why do we care about volume preserving? Like if a layer cuts the volume in half or multiplies it by 2, it hasn't necessarily killed any information. It's just rescaled the information. First question. Second question, I forgot the second question.
Well, the reason you need the volume scale, when you write down this integral, in order to evaluate this object, when you actually go through and try to evaluate it, you end up with a term which looks like the determinant of this matrix, dA. And in order for this object, this determinant to actually be physically meaningful, the determinant has to be non-zero. And in fact, the only way you can get it to be non-zero is to restrict this A to a subspace of the eigenvalue spectrum. And we know from the HCSR theory that the subspace you want is this power law tail. We have some experiments that show that in the ideal case, if you restrict the model exactly to that subspace, you can actually reproduce the test accuracy exactly. So this volume preserving transformation falls out of the math. Like if you just try to evaluate this expected value, you find out, oh, if I just assume that there's a volume preserving transformation, this equation works out very nicely. Then it turns out, and it turns out.
Second question, then I now realize, what's your teacher and student here? I didn't catch that.
They're just the way. It's just the teacher is just. I have some model. I have a layer. I have GPT, BERT, something. I want to evaluate it. I take the weight matrix. That's the teacher. How do I compute its accuracy? I consider all possible random weight matrices which look like the teacher, and I just consider their overlap. This can be derived analytically. Like you can show that this is related to the free energy of the layer, that is the quality, and so you can use some. This actually falls right out of the statistical mechanics if you assume you're in a high temperature, in the annealed case, in a high temperature. It's a generalization of a model from the 90s called the student teacher model. For perceptrons. So if you look at like a perceptron and you try to compute the generalization accuracy of a perceptron, it turns out the accuracy of a perceptron is exactly related to this overlap between the student and the teacher.
Okay. I think Pratik also has a question.
Go ahead.
Jump in.
Yeah, hi. So I had a question like since you mentioned about the layer convergence that you're trying to look at. So are you also looking at something like early layers, like early exit kind of work also in this setting? Like where you...
I'm sorry that the noise is I'm not hearing you clearly. Can you restate or someone else can restate if they can hear him?
Yeah. So my quick question was that since you is it better right now or
a little better?
Yeah. So my question was that since you're using you had mentioned about the layer convergence aspects like for specific layers, are you also considering things where in literature like people have considered like things like early exit layers, like early layers, whether they're confident about let's say specific classification task or not? Like,
I'm sorry, I just can't hear you. If you could type it in the chat, I'd be happy to answer. I just can't hear you. There's something muffled on my sounds on my side. Let me see what it says. In the meantime, while I was saying that there's also something else that comes in. There's another reason why you have to restrict to a why you restrict the space. And the reason is when you evaluate this integral, this is a complex function. The result of this is a complex function. It's an integral over this R transform, which is a complex function which represents the cumulants of the distribution. In order for that object to exist, because it's complex, when the spectral density is heavy-tailed, there's a branch cut. in the R function. If you know anything about some basic complex analysis, you have to, in order for this integral, where'd it go? In order for this integral to be physically meaningful, you have to restrict the integral to some minimum eigenvalue. So you have to start at some minimum eigenvalue and then go to the maximum eigenvalue, the eigenvalue you're at, in order for this integral to actually be analytic and to converge. And to do that, you get a branch cut, and the branch cut appears to occur exactly where the tail starts. And in physics, this would be so this is actually a non-trivial result. And it's another reason why you have to actually do the restriction. So this appearance of the branch cut and the fact that the branch cut starts where the power law tail starts is an independent confirmation of why you need to do this. Now, let me see. What is a volume preserving transformation? Do you mean that there is some transformation which preserves the determinant of some matrix? Yes. Yes, the volume preserving transformation is such that if you this is the trace log of the eigenvalues is the log determinant. So these two objects. So the log determinant is the trace log. I think by volume preserving it means that the product of the eigenvalues transformation is the same as the way. Yeah. Product of eigenvalues is 1. That's right. Product of the eigenvalues is 1. My question is, in your setting, are you considering things like confidence measures, whether early layers are useful or not? No, this is a single layer theory. So in renormalization group theory, there's this idea that as you approach a critical point, or what a computer scientist might call a fixed point, what happens is things like fluctuations and interactions with other parts of the system become negligible. So this is part of the argument of why you can make a single layer theory and why it seems to work, is because you're approaching a fixed point, which acts like a critical point. You can actually, in the ideal case, you can do things like ignore the behavior of the earlier layers. And that's one of the critical things of why relating this back to a renormalization group transformation allows you to actually build a single layer theory. I hope people can still hear me. I'm not hearing anyone talking, so.
Yep, we can hear you.
Okay, good. So I'll just we kind of got the 12 minutes, right? That's all I wanted to say, is that's sort of and I can only present so much in 10 minutes. The only other thing I say is we have a lot of experimental evidence showing that when the alpha power law is 2, that this ideal learning, this volume preservation transformation seems to hold. We can do it in cases, again, you can sort of make plots with the tool, and you can see that as the alphas approach 2, the x-axis is the HCSR theory and the y-axis is the Seidel theory. You can see they start to converge, and you can see signatures of this in various empirical models, VGG, ResNet, VIT, DenseNet. And I have an open source tool, and you can test the theory yourself using the open source tool, and a number of blog posts on this. So that's what I wanted to present, and just sort of see how, sort of what's confusing and what's not confusing, and try to answer questions around it. So I'll stop there. And thank you guys for giving me a chance to present this. And if there are any other questions, I'm happy to answer them.
Any questions for Charles?
Yeah, I said in the chat, I'm really interested in the idea of a transformation that preserves the determinant of the matrix, because I'm sure it's unrelated to what I'm thinking, but I'm just curious because it kind of sounds like this idea in optimization where you have to preserve the determinant of a matrix while reducing a lattice so that its basis is unimodular. I'm sure it's unrelated, but I would still
I don't know. It could be related.
It's probably unrelated, but I just want to know more about it.
If you could send me a note, I don't know much about that. I'll look into it. That's kind of why I presented this. Look, I think that there are probably a lot of relation. Like I basically rederived. I should comment that my undergraduate professor won the Nobel Prize for renormalization group theory. So I sort of had it in the back of my mind when I was doing this work. And I didn't realize that I had actually rederived the exact expression until I started actually writing up the manuscript. It's quite possible that this idea has sort of, diffused into other fields, or maybe it was discovered independently. And I would love to see that, because I just don't know I don't know much about optimization theory really. So it's quite possible.
Yeah, I just wanted to know like which paper I can read to learn more about this because
Oh, I have a Discord channel. If you ping me or you go to WeightWatcher community, we have a Discord channel. I have we have a long paper I've written on. It's about 120 pages, and a number of blog posts which explains it. And I'm just sort of sharing the paper now with people to get feedback before we submit it for publication. It's basically done. They're just trying to fix the typos. So if you
I
ping
can
me,
email you. I try not to use social media, so
I'm happy to send you a copy of it. Also, that's fine.
okay.
Hey,
I'll
Charles, your email is on the first slide, I believe, right?
Yeah.
Ender could email
Yeah,
you.
here I'm here. Where am I? Yeah, you can just send me an email to calculate the content.
Great.
okay,
If
thank
you do
you.
that, I'm happy to send you a copy of it.
And
I
share.
actually could use the feedback. You know, when you come in this space from a different, I mean, you know, if I had written this paper in 1998, a lot of, you know, it wouldn't be so bad. But the field is really advanced so much. It's difficult for me to know these. I don't really know these connections, so that's really helpful to see. Maybe there is a really deep connection there.
Yeah, I think in this era of spending tons and tons of money of scaling models as big as we can push them, I think this type of work is quite important to make sure we're not doing something stupid to the tune of, say, $80 million, right?
Yeah, well, you know, I don't have access to supercomputers and data. So when I started working in this, I realized, gee, you know, I have clients. I actually got involved with this because I had a client many, many years ago who wanted me to create fake text for things like weight loss articles and Amazon reviews. I'm like, you know, I have no way to evaluate this. We're generating 50,000 pieces of text every month. I have no idea, you know, I need a theory which can tell me what's going on. There's no way to brute force it. So it sort of came out of that, but also just that, you know, it's just this has been a passion project for about 10 years. And this result that I sort of in some sense it's very simple, and at the same sense I think it will connect to a number of people like Inder, is that how you say your name? Has pointed out. So I think that's very helpful. Thank you. Okay.
Thanks again. We
Thank
should
you.
probably move on
Thank
with
you.
the final presentation, just in the sake of, in the interest of time.
Yeah. Mahi, you here? The final one, I think we have RFP.
All right, hello everyone, can you hear me?
Yes.
Okay, yeah, so can everyone see my screen? Can I get a feedback on that? Yeah, okay. Yeah, hello everyone. First of all, my name is Mahi Aminaliu, and yeah, I'm part of ML Collective. Yeah, Nigeria to be specific. And like what I'm here today is basically just an idea that I've been maybe doing research for quite a while. And yeah, it's about time I kind of put on my idea together and maybe get feedback from you guys. So the idea is probably can we have a more of can I say more of like a pretrained model for water quality applications? And at the end of this presentation, I would love to get constructive feedback from all of you. And is my problem clear? And how do I expand and refine? And this is just basically yeah, I would really love if you guys can give me a proper guide on this, and I'm really excited to have your feedbacks. So, just a brief background on water quality domain or research is like the earliest what can I say, the earliest way we measure water quality or water source or water quality sample is by it's being introduced in Germany in 1848, and basically it's just simple as this. They will just know if a particular organism or substance is present in the water or otherwise. So that would basically indicate if a water sample is clear or can be used for a particular purpose. And yeah, so like Abasi and yeah, about 2022, this book basically just bring out that approach, and you are just using expert knowledge on knowing water is safe and for irrigation, drinking, and aquaculture. So this shows that this cannot be used by various people. Water quality assessment is just to the expert. So that's when Houghton, that's when there's this concept in the earliest 1922, where in the field of economics and commerce, where they're using just a single index to know if the market based on various prices of market, if the market is cheaper or expensive. So that's when Horton decided to carefully select 10 water quality parameters and apply with just basically which of the water quality parameters are of importance and which are not, and he will compute some indices, aggregate them, and then he compute the final index. So far, Houghton is basically the first person to propose a novel idea of just getting water quality index to have an idea if this water quality is good for particular purpose, drinking, irrigation, water treatment, and stuff. So, and yeah, from then, institutions, researchers, institutions like National Science Foundation and the Council of Ministers of Environment, an institution based in Canada, start to propose variants of water quality, models index for various applications in the for measuring water quality from wastewater, groundwater, and stuff for various applications, and also researchers on that. So, now becomes the major issue is how can we select the optimal parameters to give us the right water quality index that we are looking for. Because things like selecting the best parameters will also give you the right water quality index you are looking for. And that was when we have the fuzzy logic. That's when fuzzy logic comes in, and what basically this is researchers or group of researchers expert in the fuzzy logic scheme will just sat down and drive a set of rules that will probably at the end of the day, just basically leveraging expert knowledge in fuzzy logic system to determine water quality index of a particular water source or sample. So and then ML become mainstream, and researchers began to basically employ ML to learn basically machine learning to know which of the water quality parameters are influential or important. So for instance, like our just these are just recent studies. Use PCA, principal component analysis to know the most influential water quality parameters, and also use XGBoost for something similar to this. So that was when the application of machine learning, probably the planning, become prevalent in the water quality domain. So machine learning is now being used to model the inherent characteristics on the non-linear relations of the water quality parameters. Basically, to know particular pH, or one of the indicators of water quality. So with the adoption of ML, we now have reliable water quality index (WQI). We now have reliable water assessment scheme, and we are now able to forecast water quality for the next few days. And also we have improved monitoring systems for systems in irrigation, water quality treatment plants, and so you name it. So from that, then like these are the basically some of the applications of water quality, just to name a few. And like that is what you will notice is that all this water quality research, I guess this is like what I'm trying to solve here. All of these water quality research are basically location independent. There is all the data that's been used to train a particular region. Honestly, to the best of my knowledge, whenever I come across water quality research that propose a study or framework, the data that they're generally just trying to solve a problem of a water sample of a particular region, and yeah, that's it. So location independent, and with that because these are available proposed models are being trained on region data set. I guess adaptation of these models to separate region that won't be possible, right? So and also like you know um, And the studies I've read so far, like in water quality, they all almost propose almost, I don't know, near perfect accuracy. So I guess that's, and that isn't the way that you can know if this they are true. So basically, there isn't any available benchmark out there that you can know if there's water quality system, what a proposed study is, yeah, doing well. So I guess that's like basically what I have so far. Maybe the
Mahi,
issues are.
Mahi,
Yes,
can
sir.
I ask, when you say studies report near perfect accuracies, what's the accuracy here? It's some ground
Yeah.
truth
So I
mapping from the many characteristics to a single score, or what do
yeah.
you?
So if I get, I mean, like that basically using classification accuracies, and you'll have it result up to 95% accuracy. I don't know if I understand that. So that was what I mean by near
Yeah, I
perfect
guess what
accuracy.
are classification? What are the two classes here?
Yeah, it depends on the study. But mainly for portability, that is if the water is
Hmm.
drinkable, or grass, maybe if a particular indicator is good or bad from the rest of the water quality parameters. I hope it makes sense.
Hmm. Hmm.
Okay, all
Uh,
right,
I have
no
a small
problem.
question about
Okay.
the water. So I don't know anything about water and water quality, and so the question is, have you guys considered if correlating with data sets about the public health publish about the disease cases which are related to water, like for example the how many times are the symptoms of diarrhea being present in a particular community over a long period of time, and correlate this with the water quality reported numbers. Or maybe have you guys considered doing like creating a data set where you have somebody with a microscope and go count the number of bacteria or microbes in the water to have an additional data point, so that all this math can be convalidated with some real world effects, like increasing bacteria, or for example in the increasing disease and the impact on the population. Second question is, have you guys considered correlating your data with water usage, under the idea that if people are not using the water very much, then maybe that means that the water they people they feel is contaminated, so they only use it when it's absolutely necessary. But in communities where the people use the water more freely, that will probably indicate that the water has more quality and is safe to drink, is safe to use. So the usage increases will correlate with like perceived higher quality, because like if I go to a small town, I don't drink the water. That means I'm regulating myself, right? But you still have to kind of do it. So that was my question.
Okay, I understand. Yeah. So yeah, I could say I'm not expert, but I'll take these questions as your valuable feedback and input. But basically, if to get your question right, just how we can use the correlation to some understand some of the qualities of water, how we can use diseases to know correlation of diseases to know if a water quality source is safe, and how we can use correlation to based on the usage of water quality, we can use that to know if what particular water source is safe. Did I get right?
Yeah, I'm just saying that maybe one way to evaluate the water quality index measurement systems is just to measure the impact on the population, like the how often they get sick, or like if they use the water or not. Because
Yes.
the health people, they usually have statistics on everything: how many people are sick, how many people are sick of what disease. The CIE-10 classification of diseases maybe can have some specific diseases which are very correlated with water problems. So I'm not a doctor, so I don't know which ones they are, but I'm sure it must be thousands which are directly linked with bad water. So maybe if you go to health data sources, you can combine the data points in time maybe that can give you. I mean, it's not going to be a perfect, mapping, but maybe it can help.
Okay, understand. So how we can combine various data points at the same time to find these correlations, right?
Well, you need the timestamps of
Yeah,
the measurement of the water and the timestamp
yeah,
of the disease of the patient.
yeah, yeah. That's like a good point. Thank you so much.
Another question, Mahi. What data do you have access to here, or what
Yeah,
data exists here? I see you mentioned a study
yeah.
by WHO 2024. Clearly, they had some data. Is that public? Can you access it as well?
Yes. So, here in Bauchi, Nigeria, a state in Nigeria, I've collaborated with a treatment plan here in my state, and we're able to collect data of up to 6 years. So I'm planning to use that, and yeah, like my future plan on how we can get various data is basically by just reaching out to all these purpose studies and requesting we get data from them. So that's my plan. But currently I have data, but that data is not of high magnitude.
Okay. If the data is out there, but it's not clearly easily accessible and public, one important service you could provide to the community is just getting the data together, making it clean and in a standard format, putting it on, in a GitHub repo or linked to from GitHub repo where you have a notebook that can just load it quickly and plot some basic characteristics. As long as there are no kind of privacy or security issues, that could be super useful.
Wow. Wow, thanks so much, Jason. I appreciate this input.
Yeah.
So, where was I? Yeah, so that was, I think I was just like, discussing about the issues. And yeah, so that was, then I proposed, like, can we have a water quality model, being trained on large data set. So yeah, that will also achieve, state of the art performance. So I don't know if maybe probably being me optimistic. And in answering this thing is, I guess if you are able to just have a single pretrained model, researchers won't have to train a water quality model from scratch with their own region, and they can just go ahead and basically fine tune the pretrained model with just relatively small data. Because I haven't mentioned this, but we can only get so much data, and it's basically low scale. So what I'm basically saying is just maybe a foundational slash maybe creature model. And here's another issue. I guess I will like for the data I've collected so far here is there is small scale. I think because of the limited parameters, and we can't have them in very much large scale. So that would mean that without we are in the model of large creature model, ChatGPT, and we have data all over the internet in huge amount of quantity. So but if to say we are going to have a pretrained model in water quality domain, that will be probably less likely because that data cannot be obtained because they are all just table data. So I was like particularly like I just have interest in causal representation learning and especially representation learning. So basically, can we employ causal representation learning, invariant learning, and transfer learning to have some sort of domain generalization and adaptability? And when you have this fine-tune model, this pre-trained model, so that was like basically I was proposing. And yeah, so with that, I guess I was like particularly inspired by Billy Chuck. He proposed a causal transformer for medical tasks where basically just answer a counterfactual question. That is, if someone is suffering from this particular disease, probably if that person has hasn't been indulged in one particular activity, would that disease have like become chronic or something like that? So basically, that's what I'm proposing. Yeah, so by basically employing one of these domain adaptability and generalization techniques, probably with little data we can get, we can have a more of a better model that will basically generalize across various domains, transfer mechanisms learned from one particular data to another. So that's like entirely what I'm proposed. So in conclusion, yeah, there is you know, all this like the water quality domain, ecosystem have been proposing, various ways, various variants of machine learning models, water quality index models that are out there. But I guess I haven't come across a single just, water model, just like ChatGPT. You can just fine tune ChatGPT on your own small data and, have a state of the performance without, spending a lot of resources. So I haven't come across a foundational model for water quality, and I'm proposing probably, we can leverage those domain adaptability and generalization techniques to build a foundation model. And lastly, by providing this, we can, have scalable solution, minimize resources, and, we have a universally adaptable technique. So thank you for listening to me. Yeah.
Yeah, thanks for presenting, Mai. Any questions?
Are you currently working on this yourself, and are you seeking collaboration or resources?
Yes, yeah. I am seeking like all I can get. I'm seeking a mentor. I'm seeking collaborations and also resources. Yeah, like just to be personal on this, my dad is actually working on the treatment plan where I collected the data, and like I really see where I can employ my skills, machine learning skills to, um, you know, revolutionizing his work. So I'm not expert in water quality. I could leverage an expert in water quality domain. I can leverage expert that I build all these existing machine learning models and stuff. So yeah, I'm looking for collaborations. Thank you.
If people are interested in working with you, how should they get in touch?
Yeah, I guess I have link to my website, and that website has my email, but I can send it here, like my email.
Yeah, your website is linked
Oh,
on the page.
Oh yeah, I see it now. I see it now. Yep, in your
yes,
Gmail.
yes,
Great.
yeah. Thank you.
Yeah, it seems like there's a lot that could be done here. I would suggest there's a couple possibly profitable directions you could take this. One, if there's not much out there yet and it's a little bit of a mess and there's different data sets, but there's not a single one that everyone accepts nor a single benchmark, then your first contribution could be clean up the data, get it all in one place, and make a benchmark for some downstream, literally maybe downstream tasks on water quality. Then try 1 or 2 or 3 stupid baselines and just publish how well they work. Don't even try some complicated transformer, etc. model. If there's already benchmarks and data sets and baselines and people have published a few different models, then you can possibly do the second type of paper, which is a modeling paper where you try to come up with a better model for an accepted task that already has good baselines. So then you could maybe try some fancy transformer or whatnot. But basically, if there's not already a good data set and a good benchmark and good baselines, just starting with fancy models is probably the wrong place to go. You need to establish that foundation first, and then you can bring in your favorite models. But overall,
Thank you so much, Jesse.
For sure, yeah. And as always, we'd be happy for you to come back and present, the first step of the project, what you did, or what you did with collaborators, if you find anyone to work with.
All right. Yeah. Thanks so much. I'll be happy to do that. I'm really glad for all your feedbacks on this. I guess I'll be heading to the right direction. Thank you so much.
For sure. We're at time, so we should probably wrap up.
Yeah, let's thank all the presenters.
Thank you.
Thanks everyone for coming and participating.
Yep. Thanks all.
Yeah, hope you make good connections, find things you're interested in, report back what you find or what have come into your life out of this meetup. Right, see you next time.
Thank you.
Bye, guys.
Bye.